Okay, so in the polar, talking to Matthews and Mirzwa, pre-calc, college trig, college algebra, parametric, you did not do that much, but you did do more polar in pre-calc or college trig. Last year you guys looked at like rose petals on Desmos or on your calculator and how it kind of loops around and makes these type of shapes, okay? So we're going to be looking at those more. The big thing is polar, pole. Pole is the origin in kind of polar world. Everything spins around the pole. So that blue circle up there at the top, it's very hard to write an equation for that in polar form because it's not centered around the origin. It's centered around the dot way over on the right and up. So I want you to think of the tetherball game that I was saying earlier where you're swinging some ball around the origin, around the pole, and the rope gets shorter, the rope gets longer, but it's still based off the origin. Okay? So now, two ways to describe polar. It's about the r and the angle. And now in the order they write it, they say r comma theta. So it makes you kind of think if I say something like 5 comma 45 that you make your radius 5 and then you sweep it up 45 degrees. You can do it that way. My brain triggers it even though it says r comma theta, I think of the theta first. So I kind of think of rotating my head up 45 degrees and then shooting out 5 to lock in the dot. It's kind of your call on how to do it. Do you want to start with the length and then rotate that length up? That way you'd kind of think of like creating a minute hand or an hour hand, always pointing on the clock to the number 3, and you set the length first and then spin it up. Or you can rotate your head first and then shoot out like a laser, like Cyclops, to the certain number. Now you can have negative radiuses. So a negative radius is thinking backwards. So in the world of thinking backwards, if I do negative 5 comma 45, I am looking at 45 degrees, which is like northeast, but my radius is back 5. Okay? So in that world, I kind of think about like when you hear a mom or a dad or a teacher say, hey, I have eyes in the back of my head. I want you to think of that Cyclops vision where if I'm looking at the board, I can still see what everyone's doing because I have the eyes in the back of my head. So that's your negative radius idea. What was it? Mad-Eye Moody. Exactly. Look at our Harry Potter references. Mad-Eye Moody has the negative radiuses. Okay? Mad-Eye Moody. Oh, wow. All right. Read the books. Okay. So another way I think of it is the chomper idea from Mario. Okay? And so the chomper idea from Mario, the chain link, the chain of the Mario is the radius. And then you can have your angle part. So in here, I'm showing 4 different versions of spotting the same chomper. You either have the radius as 8 or negative 8. And your reference angle is either the positive 135 or a negative 45, but then you look at it backwards. So the purple, you can kind of see it here. My purple was look down, but then shoot it backwards out 8. The teal would be where you're doing just 315. So you go, oh, that should have been teal. Sorry. Teal. Oh, yeah. Teal 315 and then shoot it back. So there's different ways that you can have positive angles, positive radiuses, negative angles, negative radiuses, or one of each. You guys okay with that? So really today we're focused for the most part on just plotting the points. So here, I give you rectangular, and I say I think we can get some polar stuff out of this. And I kind of walk you through what I think are some of the easiest conversions to what you need to find all the way through. 0, 6 in rectangular. 0, 6 in rectangular is due north up 6. So what angle is that at? 90. How far up am I? 6. So that'd be 690. Could you also say 6 comma pi over 2? if you're in radian world. All the calc will be based off radians. Okay, all the calc will be based off radians, but I'll do a lot of your referencing based off degrees, because you know degrees better than you do radians visually. -8. What do you got there that's super easy? Theta is 135, because you're in the top left quadrant. Okay. If I see a 3, 4, -3, 4, or 3, -4, any of the 3, 4s, I think you would know the R pretty quick for the famous Pythag. So you have 5 comma something. And then if you're at 7, -2, I think you're starting to figure out the radius. And I think it's pretty close to knowing how to get the angle. But I don't know the angle right away on this one until I start drawing the picture stuff. And two things that pop out of the picture is your radius is based off the x component and y component. Last hour preferred me to write it as r equals, but you also might like seeing it as x squared plus y squared is your r squared. So it's just Pythag to get the radius. And then tangent theta is y over x. I asked them about why I chose tangent theta, because you could have chose sine theta, you could have chose cosine theta. What would sine theta have been? Y over r. And I told them the only kind of issue with that is I'm asking you to convert from rectangular to polar, which means if I'm starting in rectangular, what do I already own? The x and the y. So then I'm using tangent because I already own the x and the y. You can totally do sine of theta equals y over r. What do you have to go find first though? R. So why they say tangent is because it clearly separates, like if I highlighted this, it clearly separates rectangular stuff is the y and the x, or the x squared and the y. And then the polar stuff is r by himself or the theta by himself. If you wrote the sine guy, it would be kind of a merger. So like I could write sine of theta equals y over r. But then the weird part is your conversion has r is the polar, y is the rectangular, and the theta is the polar, and it's kind of blobby. Linnea had a question. Yep. Great question. So for the video, Linnea said, okay, r is always the square root of x squared plus y squared. When would it ever be negative? Look on the right side here. Are you good with that one? Can I make it positive or negative? Where am I lazy on my equation of the left one? It really should be a plus or minus. What would we normally go with? Positive r. Almost all the time you would rather have a positive r and you'd rather be looking in the direction of where the dot is rather than looking in the opposite direction but making a negative r backwards. So if you have a choice, go with a positive r. But you can decide to go negative and be sly and look the other way. Okay. Now, go get me the 7, -2 guy. I left that one completely blank. Why don't you go get me the 7, -2 guy and write it in a polar kind of coordinate set. I'll hit pause for a brief second. Okay, so on the inverse tangent one, some of you will prefer to just do inverse tangent of all positives and then pick and choose where that angle goes. Some of you would rather keep the negative in there. Either way, it's at -15.9. Could you, if you wanted, said like 345-ish? Okay, you could go that route and reroute it all the way around, or you can just keep it as that quick negative angle. And then the Pythag square root of 53. So then I typed it in 3 different ways for the -3, 4. One way, could you do it with all positives? Could you do it with, which guy had the negative? The 3 did? And could I do it where the 4 has the negative? Now, it would be awesome if a calculator was this smart, but it's not. Do you agree negative 3 comma 4 is a lot different than 3 comma negative 4 in the world of rectangular? One of them is back and up, and the other one is forward and down. So second quadrant versus second quadrant versus fourth quadrant. But on these two here, the calculator does not put ownership on a number for the negative. Both lines there, the calculator reads it the same. That's why the answer is the same at the negative 53. Okay? It doesn't say, ooh, the 3 has the negative, so we are in the second quadrant. Ooh, the 4 owns the negative, and we're actually in the fourth quadrant. It would be awesome if it does that, but it doesn't. Remember, inverse tangent only outputs things from the first quadrant and the fourth quadrant. The guy I want's in the second quadrant. So none of these answers are correct, no matter how you type it in. You have to outsmart it and force it into the second quadrant. Could you use negative 53 and make your radius negative? Sure. But I think a lot of you would have rather had it be 126 and kept the radius positive. So be very careful on your inverse tangent that what you get out of the calculator is not the angle that you need. It might be, or you might need to add 180 to it to get it into the spot that you need. The best way to answer that from me to you is know your rectangular spot. If your rectangular spot is in the second or third quadrant, be careful. If your rectangular spot, like that first guy 7, negative 2, was in the fourth quadrant, you don't have to be as careful. Did that answer your question? Okay. So, yep, talked about that. Told you about this. Oh, on this, the stuff in the black is how you can convert back from polar to rectangular. If I color code again, let's see, it looks like I color coded a different way this time. Yep, I did. Okay, so here, color coding, really look at the bottom stuff. I color coded it differently than a couple minutes ago, but I already did the tangent theta is y over x, and I already did the x squared plus y squared equals r squared. If you start in polar, then you don't use the tangent, you use the sine and the cosine, which is just, again, basic trig to get your guys. Okay? Half of this homework is about converting from rectangular to polar and polar to rectangular coordinates, which is literally using 1 and 2 and just rewriting. Okay? So here is stuff about, here's polar, go to rectangular. There's your answer. It's going to be, you'll see it in the notes. Here, same thing. Okay, rectangular to polar. Okay, what I now care about is this part, and this is the last couple minutes, and it is, so I hit pause so people could write. So now I got 1 minute left before bell rings and the timer goes boop. Okay, this is ways to convert equations, not coordinates, but actual equations. Okay, so 4 different ways. A and C might feel the same because r times r is the same as r squared, but it's what happens to the right side of the equation that you'll make a difference with. Okay, sometimes if you multiply by a cosine or a sine, you can make an xy conversion, and sometimes you just have a flat theta by itself, and if you do tangent of it, immediately pops into a y over x. Down low I have 3 different versions that are very simple conversions of the 4. You can see my color coding of it. The bell's about to ring. Just give me the 40 seconds to go through them. I'll start with the blue one. Blue one I'm going to multiply by cosine, and this is y. So if I multiply blue by cosine on both sides, what happens to secant theta cosine theta? It becomes 1, and r cosine becomes x. That's a way to do a polar version of a vertical line. Next one is the theta equals pi over 3. If you do theta equals pi over 3 and do tangent to both sides, you get y over x is the square root of 3, which is y equals square root of 3 of x. And it's that. And I really want you to realize that, know what locks in on that line? That